Hello, amazing hackers. I hope you're all doing well today. For some reason, I've been stuck in this TV for a couple of days now, and I can't seem to get out. This doesn't make any sense. This is not logical at all. So, if it's not logical, let's talk about logic vulnerabilities, shall we? Talk about a segue. So, logic vulnerabilities, you're not going to find a lot of information about logic vulnerabilities out there. I challenge you right now to pause this video, go into Google, and search for business logic vulnerabilities. You're going to find a few very good articles on it from Portswigger and other stuff like OWASP, but it's very, very limited. You don't get the concepts explained properly, in my opinion. So today I really want to talk to you guys about what logic is and how it can go wrong. So let's talk about logic vulnerabilities, shall we? Because I do believe that logic is something that you can train and that there are things that help you improve the process. We're going to go over those and much more in this video. So let's talk about logic first. Our logic is always flawed. It's as simple as that. It's a harsh statement, but it's something we have to realize. There's nothing wrong with that. As long as we are human, we are going to make mistakes, and we simply suck at foreseeing the future. It's as simple as that. We suck at foreseeing all the possible issues that could arise from the algorithms, from the functionalities that we implement, from the actions that we put into action. We develop many different risk mitigation strategies, but you know as well as me that ruling out every single risk is going to be impossible because we simply can't foresee all the possible variables that play into the situation. In business situations, we have the same issue, whether it be banking, a shoe store, a company that sells websites, they all run into the same issue eventually. It's something that we eventually run into our daily lives. Everybody runs into it in our daily lives. Let's have a simple thought experiment, shall we? So what I have in front of me here is I have a knife, I have a slice of bread, and I have a jar of Nutella. And I'm going to ask you to instruct me how to make a sandwich. You're going to call out a few things like put the knife in the jar of Nutella, put the Nutella on the bread, that's all good. But now imagine trying to tell it to a person who's never used a knife before, who's never seen a jar before, who's never seen a piece of bread before. That's going to be a lot harder, of course. And that's something that we often do without realizing it. We're using software of which we do have some basic idea in a sense, but it compares us like we're literally cavemen when we use that software sometimes. We have stone tools and we don't really know how to use them. We just hammer things and something magical appears. That's how most people go about hacking, about finding business logic vulnerabilities. They just try to hammer with a stone on everything that's possible, but that's not how it goes. You really have to think very carefully. And of course, if you are the person who has to design logic, it's going to be extremely hard because now you have to think that you're designing your logic for all of those cavemen. You're basically going to have to think about you developing software for people who haven't used your software before. That's going to be something very difficult. You're going to have a lot of empathy, you're going to have a lot of empathy to put yourself in those people's shoes. That's really, really important. So it's the exact same thing with software. If you don't know how to explain things properly in your UI design, you're going to have a problem. If you don't design your processes properly, you're going to have a problem. So it's basically really, really hard to design good logic is what I'm trying to say here, but it's even harder to find logic flaws because a lot of people are going to be looking at that logic, and we're going to talk a little bit more about that later. But we are the last ones to get to that program, but that does also mean that logic vulnerabilities are going to be a lot harder to find when you are looking for them with automated scanners, for example. Can you try imagining, just imagine you have to build test automation and your robot is going to have to think for itself. It's going to have to design logic, develop logic. That's not possible, you know? So automation on logic vulnerabilities is going to be really, really hard. but what really is a logic vulnerability in its core, in its essence. Now that we know and we understand the meaning of logic, we can also talk about how vulnerabilities arise. In recent times, everything needs to go faster and faster with the coming of agile methodologies. So, agile is basically a development methodology, but these issues have existed for ages. We humans just suck at predicting the consequences of our actions. And even if we could foresee all of our consequences, we can't take into account what other people will do. People are unpredictable by nature. There's an inherent risk in working on a software program over multiple weeks, months, or even years. Everyone who comes into contact with software development will be able to confirm this. The longer a project runs for, the more changes it undergoes, and those changes are going to be either in staff by hiring, in technical solutions. There's going to be a lot of changes, throughout the program, a lot of iterations, a lot of new features are going to come up. So there's going to have to be an inherent risk strategy as well, risk management strategy. So risks can be mitigated, but in my opinion, there are a couple of ways business logic vulnerabilities can always keep sneaking in. It seems to me that most companies have an allergy for documentation. They don't document what they should, or they keep it on a worker's personal laptop where it's never shared. This means that if a feature needs to be adapted or built upon existing code, the developer and analysts often don't know how old code works anymore. This is an excellent opportunity for logic issues to arise. Lacking knowledge of existing features might make it so that some properties of that feature have been overlooked, and that creates a great entry point for those juicy logic vulnerabilities that we are looking for. The lack of documentation also means that when teams have to work together or create integration points, it's really hard for them to communicate effectively. And this may in turn lead to missed properties of the feature again, which is in turn going to lead to possible logic vulnerabilities sneaking into the program. The logic is so complex sometimes that the people working on it, they'll get confused themselves. Sometimes you're working with very big systems, very complex logic, and it's not easy, and you'll have to create some kind of risk mitigation for that as well. But again, that's a very good entry point for logic vulnerabilities. And all of these things seem logical in and of themselves, but they really are not. That's why they slip through the net, and it's better if I give you some examples, maybe. But this is really why business logic vulnerabilities keep rising in my observations. And I'm QA tester. I do a lot of QA testing for companies, big companies in Belgium. So I do know pretty much where those problems arise, where those problems lay. And those are big points of contact for me. So for some examples, imagine that we have a feature to pay for an order, but it's not documented properly. The developers now have to edit the system, and after a year, they have to include mobile banking. But since they don't have documentation, they miss a piece of code. This piece of code is hidden deep inside of the existing code, but allows you to enter 999999 into the credit card field, and then you'll automatically pay throughout the application without actually having to pay. This has been done by a developer in the original code, but has been put in a method that should normally never be reached. He did this for testing purposes, and there was a debug flag around it, meaning that it could only execute in debug mode. But with the update of the logic system, the developer had no idea what this code did due to its complexity, and they put it in a payment procedure. This introduced a logic flaw because anyone can now pay by entering 9999 into this credit card field. And of course, that's a big logic vulnerability. But you don't notice that most testers, most developers will test with this 9999 value, or there are specific values for credit cards that you could test for, specific values for everything. Like testers often use these specific values to test with. Developers also use them. Why not check for them if they are not forgotten in the code somewhere when deploying to production? It's really important to always cover all your bases. Now, when you click a forgot password link, for example, this is another example. There's basically two systems that will work together, a reset password generation link system an email sending link system. So first of all, it will go through the password reset generation system where a link will be generated to reset your password. But if you enter like a payload where you first enter one email address of the victim and then an email address of the attacker in the same request, it might be that the password generation system, the password link generation system, might generate a link for the victim, but the mail sending system might see the attacker mail, and it might send the victim's link to the attacker, allowing the attacker to click it and reset the victim's password. That's not good, of course, because yeah, well, of course it's going to allow for an account takeover. So that's another example that I can give you. It does happen. We can trigger the server that generates this link sometimes to generate it for different users, but not always. This is, of course, not always the case. None of these examples are. So another example I have for you is, imagine you're a triager and you're working at a bug bounty platform, but your systems, they've gotten very complex, and to triage bugs, you have a very, very complex system now. And you might accidentally have part of your admin panel exposed to the public without even knowing it because the developers forgot to add authentication to that page. I know that's broken access control, but it's also a little bit of logic vulnerability to me. Of course, it's mostly broken access control, this one. One thing that might also happen, a logic vulnerability that not a lot of people think of. Say, for example, you have a query to log in and it's going to say select star from users where username equals username and password equals password. Now, in every single case, it should say an and there, but sometimes developers might be a little sloppy, be a little bit forgetful, and put an or there. And that's pretty messed up because then it's going to allow anybody with a username that's valid or a password that's valid to log in, which is going to be really strange and it's going to cause some unusual behavior. So, those are some examples that I could give you guys. Let's talk a little bit about the properties of logic vulnerability, shall we? Because these vulnerabilities can exist in the product for years at a time without being discovered. You guys might not know this, but business logic vulnerabilities, they have some inherent properties to them that allow them to stay undetected for long periods of time. You can't detect these with automated processes efficiently. It's really, really hard, guys, to teach a robot logic. That's not something very simple at all. These issues are inherently very hard to detect manually as well, since they already slip past the analyst, developer, and tester who have all not caught it. They range in severity from low to critical, depending on the functionality of where they are. And that's also something that helps hide them because sometimes they have a very high severity, but they don't have a very high occurrence rate. So in that case, they're not going to be seen often, but you will be you will, if you find them, you're going to have a very critical vulnerability. Now, onto what the development process can do for this specific vulnerability type. You have several different types of developing software. You have, for example, the waterfall model. And as you can see in the course, if you guys are watching this from the course, if you're not, if you're watching this from the YouTube channel, you probably can't see this, but I might release it. You guys can just Google it. But the waterfall model, there has several issues in there that can help us discover those logic flaws. So we can see at several different stages where logic flaws might occur. As we can see on the image, the requirements are created, they lead to the design of an application, and from there, the developers can get to work and create what they need to be created. The testers go to work trying to destroy what the developers have built, and after all checks have been approved, we enter a phase of maintenance, trying to fix any issues that arrive with that feature. All in all, after this is said and done, several features will be stacked upon each other to build an application, and when a new feature has to be built, this is usually not a big issue. Old code is not being touched anywhere, new code is just being created, and it's usually with insufficient unit testing. That's how we know developers. And I'm sorry, developers, but if you are a developer, please start writing unit tests very, very carefully because they are very important. If you want to look up the testing triangle, it's going to show you a little bit about why they matter so much. Usually the feature is being created without the proper documentation, also very important to know. As a project is young and still full of motivated people, and got to start with something new, something exciting, it's usually not a big problem because everybody knows what you're talking about. But later down the line, when the features need to be built upon others or refactored, issues start to arise. Or when you have these very big programs that have been going for a year or two, and you have new people coming in, old people leaving, those are all issues that might arise, and that might lead to business logic vulnerabilities because new people might want to be as adept in the application as the ones that left, and there might be some trouble and all of that. So really good points for us to introduce logic vulnerabilities, and that's where we're going to look as well. Of course, it's not something I'm saying to you guys where these issues are being introduced, but it's not like I can tell you guys exactly look into these specific things. What I'm telling you is how they develop specifically these logic vulnerabilities, and then it's up to you to see if you can find them. Just think about any piece of software and how you can abuse it. It's very important. Now, in the V model, as we can see here, every stage of design and coding is tested properly. This has some advantages and disadvantages, but appears to be less room for logic flaws in there. I agree that more basic logic flaws can be mitigated by acceptance testing here. There's still a huge attack surface for them. Above all, the waterfall model, above the waterfall model, there's also some extra complexities in here. And the more complexities, the more business logic vulnerabilities might arise. So that's usually a lot of issues. In this case, the extra complexity makes it so that it's easier for business logic vulnerabilities to be masked. Extra attention is being drawn to the process, and that's drawing away attention from the logic itself. And people tend to start focusing more on the existing user stories instead of thinking up scenarios that have not even been described yet. And the biggest attack surface for us will be when the new release hits the testing environment. This is when all the processes that have been followed and all the features have been created come together. We have to test the new features that have been developed and the old features that have been refactored. This is why it's important to subscribe to any release notes if possible. So to summarize this real quickly, test when a new release hits production, test the new features, test the refactored features, and think about how features can interact with one another and if there might be a possible flaw in that interaction. Try to subscribe to any newsletter if possible. Now, then comes the agile methodology. In agile, it's all about going fast. As you can see here, we begin by planning, we go into design phase, then development starts, we go into testing. After testing is done, we go into the deployment, we review what we've done, and then we launch. As you can see, in agile, things move in a cyclical way. Often that's a 2 week cycle, but it can really depend, of course. So there's also a big entry point for business logic flaws in here. Let's talk about regression errors, for example. Messy developers can easily have an old piece of code on their laptop and commit it, after which it gets smuggled to production in a huge code commit with many files. Now, this can also happen in waterfall and V model. Let's make that very clear, but I think it happens a lot more in agile. And I don't know why. I have no clue. It's just an observation that I've made. The developer can easily make a huge mistake due to time pressure or missing documentation. That's also something that can happen. And if Agile is not being used properly, which is often the case, then of course you're not going to win a lot either because the process has become a lot more prone to business errors. User stories are often not chopped into their smallest workable tasks, which allow for missing requirements due to higher complexity. Sprints are often way too big, taking a scope way too big due to tasks not being estimated properly. Sprint capacity being overrated. Sprints might take way too long with a giant scope, like 2, 3, 4 months with a giant scope, and that's just not the intention. That's just not supposed to happen. All of these points make it easier for business logic to us to appear, and we should definitely test new features Our targets every release cycle, of course, and the refactored features as well. Now, to mitigate all of these topics that we discussed, we have to train our brain to recognize these logic flaws. Take the time to properly analyze features and document them. Write good unit tests to prevent regression flaws, guys. That's very, very important. As for some extra curriculum activities that you can do, you can train your logic skills easily. There are hundreds of activities you can do to increase them. There are some fun things as well. There are some escape rooms online that you can play. It's a very fun way to increase your logic thinking skills and it will help you spot those details more easily. A fun and free way to get started is to look up any of the hundreds of free escape rooms that you can print at home and playing right away. I'll put those in a link in the description as well if you're watching this on YouTube. What's also very useful are these logic games, guys. Just look up a logic game. There are so many of them. There are way too many of them to count. So even though logic does seem like a hard skill to train, it seems like enough people are willing to take up the challenge and create some challenges for you. If you want some more, you have some free labs as well. Link will be in the description. Again, if you're watching on YouTube. If you're following the course, you have those labs already, of course. Thank you very, very much for watching Amazing Hacker. This was really good. I love talking about business logic vulnerabilities. So thank you so much for listening. My love to you. Uncle Rat out. Bye bye, Amazing Hacker.